Okay, so let's go for next level of angular momentum algebra. We have solved these all thing in a term of function. Now we will just use the operator, and this is the most important thing to solve the problems and solve the mathematical analysis of angular momentum. I request please uh, off your mute your mic. Okay, so let's try to go for all about angular momentum algebra. So in the last class, what we have done, we have just form a kit, and that kit is L and M, and this is equal to or equivalent to YLM theta phi. Don't worry, this is some function of theta and phi, not some function. You know that function actually. This is equivalent to P L cos theta, that is legendary polynomial, and e to the power im phi. The whole thing we can combine it as a function, and this function is known as spherical harmonics. So what we have seen, that L square will operate on L and M, that will give us L into L plus 1 h cut square Lm. So this is the eigenvalue. And yes, for the given value of L, we will operate the Lz. So L will remain same, and this will be Lm, and this will be M h cut Lm. What is the value of L? The value of L will be 0, 1, 2, 3, and the value of M will be between minus L to plus L, and delta M will be plus minus 1. I will prove it also. So right now you can just use this thing, and we have also defined two operator. One operator is L plus, that is Lx plus ILY, and another operator is L minus, that is Lx minus ILY. We have also find some commutation relation, and the relation is something L square L plus is equal to 0, L square L minus is equal to 0, and L square Lz is also equal to 0. But the next version is very interesting. We have Lz L plus is equal to h cut L plus, and we have Lz L minus, you can have minus h cut L minus. So obviously these are the story we have done into the last class, and for the problem solving case, what you have to do, you have to just remember all this stuff, at least this stuff. Now, to determine why we have done this L plus and L minus, because what we know, we just want to know how my Lx and Ly is going to behave. So why we have done L plus and L minus. So once we know what are the property of L plus and what are the property of L minus, we can know each and everything about the L operator, because we have already know the story of Lz. We have then from L plus and L minus, we know the story of Lx and Ly, and same thing we can take each and everything about the angular momentum. So let's go for the story about these two operator L minus and L plus. So up to that, if you have any doubt in the notation problem, anything, you can just ask me. Okay. So let's go for the different story.
Sir, in last bracket is L square Lz is equal to 0.
बिल्कुल, ये तो हम कल कर चुके हैं, नहीं? So let's go for this operator. This commutation actually Lz L plus. Obviously, we have derived that will be h cut L plus. So this is the thing. Now, let us try to open it. So when we will open it, then what will happen? Lz L plus minus L plus Lz must be equal to h cut L plus. What we will do, we will operate LM kit on both sides as same thing we have done into harmonic oscillator. So that will be Lz L plus Lm minus L plus Lz Lm is equal to h cut L plus Lm. And we know if Lz will operate on Lm, then what will happen? You will give mh cut Lm. So Lz L plus Lm minus this will operate on here. So we will get to get mh cut. So mh cut I am taking outside. So mh cut L plus Lm is equal to h cut L plus Lm. Now, can I write the whole story as Lz L plus Lm is equal to m plus 1 h cut L plus Lm. So there is a story. What it reveals? What is meaning of this? Can anybody tell me? What it
Eigenvalue.
reveals? Exactly, exactly. So this L plus Lm is also eigenvalue of Lz. Same. You remember the story we have also created into the harmonic oscillator, something like that. So same thing we are just getting here also. Now we know the story that Lz will operate on Lm, that will give you mh cut Lm. Now please tell me, if I will operate Lz on L m plus 1, what I will get? Can anybody suggest me? If I will operate this thing on this kit, what I will get?
plus m plus
M
1
plus 1
M
h cut.
plus
Very
H
good.
H
M
cut
plus 1 h cut L
L
m
m
plus
plus
1.
1.
Very good. Now let's try to use this relation to identify what is this L plus Lm. So if I am writing Lz L m plus 1 must be equal to m plus 1 h cut L m plus 1. And please, L square and Lz are independent. So if Lz is operating on this particular function, what will happen? It will not touch L. It will just touch M. So there is not any problem. Now look at, if you are going to compare these two things, Lz is going to compare with Lz. This thing is going to compare with this thing. This number is going to compare with this thing. Then obviously, this whole thing is going to compare, this function is going to compare with this function. Are you getting it? So can I write the whole story as L plus Lm is nothing but proportional to L m plus 1? Can I write this story? At least I can say these two are parallel to each other. If you have any doubt, you can just raise this question here. Now, so we can just write the whole thing as L plus L m is equal to C plus L m plus 1. So what will happen? When we will take the bra of this, then this will be L plus dagger. So this kit will change to bra, that will be LM, and this L plus will convert it to what? L minus, because they are the Hermitian conjugate, and this will be C plus star, and there is L M plus 1, and now we are going to multiply all these things. So what we will get? We will get L M L minus L plus L M must be equal to mod C square or C plus square, that will be L M plus 1 L M plus 1. You can just see all this story. So everybody is clear about this? Just see, just look at everything. So let's figure it out. What will be L minus L
सर
plus?
सर एल प्लस का
बोलो।
कंजुगेट एल माइनस ही होगा।
बिल्कुल, आप देख लो। Lx is equal to, sorry, L plus is equal to Lx plus ILy, L plus स्टार करोगे तो Lx स्टार minus I Ly star. Lx star is Lx minus ILy, and that will be nothing but L minus, isn't it?
थैंक यू सर। यस सर।
So let's go for calculating what will be L minus and N plus. So let's try to figure it out. So what we have actually LM, and please, these all derivation are very important for your examination point of view. L minus L plus LM, and yes, this is normalized. We have given you the normalization condition in the last class. L is equal to L, M plus 1 is equal to M plus 1. So this is normalized. So what we will have? We will have, this will be mod C plus square. And now let's try to calculate what will be L minus L plus. So L minus L plus is equivalent to Lx minus ILy into Lx plus ILy. And now this thing is actually Lx square plus I into I minus 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 plus. So this will be Ly square, and Lx and Ly. So you can take I Lx Ly minus Ly Lx. So what is this? This is nothing but the commutation of Lx and Ly. So you can have Lx square plus Ly square plus I commutation of Lx Ly. Now this thing is all about Lx square plus Ly square plus I into I h cut Lz. So what will happen? Can I write this whole thing as L square minus Lz square? Can I write this whole thing as L square minus Lz square? Because L square is Lx square plus Ly square plus Lz square. So, and II is minus, so this is minus h cut Lz. So L minus L plus is this thing. This is equivalent. Because why I have done this? Because the known result is only given for the L square and Lz. So what we have to do? We have to just go for change the operator as a L square and Lz, or Lz square. There is not any problem. So this is the story. Okay. So let's put this thing here and we can get the value of C plus. And this is very interesting. Now, this thing can be written as Lm, and this will be L square minus Lz square minus H cut Lz Lm is equal to mod C plus square. Now, L square will operate on L, that you will give you L into L plus 1 H cut square. Lz will operate twice, so this will be M square H cut square minus Lz will operate on this. This will be M H cut square. This H cut is M H cut square, and here is Lm. Lm, you have this is equivalent to mod C plus square. So mod C plus square can be written as L into L plus 1 minus M into M plus 1 H cut square. Isn't it? Are you agreed? Now you can see this number must be always positive. The norms cannot be negative. This number is always positive. So what will happen? M can never be greater than L. So there is upper bound of M, and we can say that M is always less than or equal to L. Then only this number is positive. So we know that norms can never be negative. So why we have used this expression. And finally, I have a wonderful expression. What will be that? L plus Lm is equivalent to root under L into L plus 1 minus M into M plus 1 H cut L M plus 1. And here we can write L plus, if M is equal to L, then this value is 0. So you have this wonderful story. If you have any doubt, you can just ask me. Otherwise, I will go for next calculation that will I will talk about in the same way about L minus. And look at what is the role of L plus. The role of L plus is L plus will operate on this Lm. You will get one state ahead. So this is something called a raising operator. And please, it's just keep this L value same. The small L is same. What is going to change? The M is going to change, but you are into different state. So for the given length, the direction is going to change in the azimuthal term. So this is all the story. But there is some upper limit. So M cannot be greater than L. So this is the story. So should we move ahead? Okay. So in a similar fashion, we can also use this formula Lz L minus is equal to minus H cut L minus. So same thing we are just going to do, that is Lz L minus Lz is equal to minus H cut L minus. We are just going to operate Lm kit minus L minus Lz. Lm kit is equal to minus H cut L minus Lm kit. So now again Lz will operate on M. You will have, so I am writing it directly. That will be M minus 1 H cut L minus Lm. So what we have again? You have eigenvalue m minus 1 h cut. And if I will compare this whole story, Lz L m minus 1 is equal to nothing but m minus 1 h cut L m minus 1. Same way. So again, what I can say? I can easily say that L minus Lm is proportional to L m minus 1. Same story. Same story. I am just going to repeat again. Not any new thing. So I am just doing very casually. So what you have? You have L minus Lm is equal to C minus L m minus 1. I can have this number. So again, we will take the conjugate of this. What you have? Lm, L plus, L minus, and that will be C minus star. That will be, sorry, this will be L plus only. This just take the conjugate, you will get L plus. That is L m minus 1. What you will do? You will just do the multiplication. You will have L m L minus, sorry, L plus L minus. So this will be L plus L minus Lm is equal to mod C square. Here is L m minus 1 L m minus 1. So this number is 1. So we have to just calculate L plus L minus. So let's try to calculate what will be L plus L minus. So always remember what will be happen L plus L minus, what will be happen L minus L plus. So these two are very important thing. So L plus L minus is Lx plus I Ly into Lx minus I Ly. And again you have Lx square plus Ly square. And this time you have I Ly Lx minus Lx Ly. So this is the story. What will be this value? This value is nothing but the minus Lz. So again we can write Lx square Ly square as L square minus Lz square, and this will be, you have plus h cut Lz, because minus I into I is equal to plus, and that will be h cut Lz. So again we will plug it into this equation and we can get the solution. So let's go for the solution. Are you getting this thing? That is same thing we are repeating again and again. So एक कर लेते हो तो दूसरा अपने आप हो जाता है. If you have any doubt, you can just ask me. Are anybody there or everybody is sleeping?
No, sir, not out.
Sir, no doubt.
Yes, sir. No, sir.
Because there is pin drop silent. Nobody is talking anything. So let's put it here. L M L plus L minus is all about L square minus Lz square plus h cut Lz, and that will be Lm is equal to C minus mod square. You can again get this number, that C minus mod square is equal to L into L plus 1 minus M, and this will be h cut square, M square, h cut square plus M, h cut square. And now you can write C minus mod square is L into L plus 1 minus M into M minus 1 H cut square. Now again, this number must be always positive. So the value of M cannot be less than minus L, because M is equal to minus L, this thing will be 0. You can just check it. M is equal to minus L, this thing will be 0. And if M is less than minus L, this thing is negative. So you cannot have this particular thing. So we have the lower boundary that M should be equal to minus L. And what will be C minus? And C minus is equal, and you can just write L minus Lm is equivalent to root under L into L plus 1 minus M, M minus 1, H cut L, and you will just lower one state of M. You will just lower one state of M. So that will be M minus 1. And yes, if you will check it, L minus L, that will be 0. This will be 0. So what we have seen? We have seen the value of M. I have promised you that I will prove it. The value of M will be minus L to plus L. And you can see L plus will just raise one level, or it will just decrease one level, or L minus will just decrease one level. And we have seen that the value of M is itself discrete with the unit of 1. So 0 plus minus H cut plus minus 2 H cut. So we have this delta M is equal to plus minus 1. This is the story. And we have just created all the story of L square. Once you know this Lx or L plus, you can easily talk about Lx. Once you know this thing, you can easily talk about Lx. What is Lx? So you have L plus is equal to Lx plus ILY. L minus is equal to Lx minus ILY. You can add it, then you can have Lx is equal to L plus L minus by 2. So you have this operator once, and you know what is the story of L plus and L minus. You can figure it out each and everything. So if you have doubt, then you can ask me. Otherwise, we will just go for next 25-minute problems and next 1 hour again problem.
Understand everything, sir, what you teach till now.
Okay, okay. I am just talking about other people who did not understand this thing. Okay. So let's try to go for different type of problem. First, I will summarize each and everything. Then we will go for different type of problems. Okay. And I will also give you what will be a spherical harmonics, different types of a spherical harmonics, such that you can just use this thing into solving your problem. So let's go for the summarization of all thing what we have done. So please, this story is very important and you have to practice it very hard. But for the examination purpose, whatever I am going to write in this particular board is more than enough. So please just use this concept to solve the problem. And you know how this concept is derived itself. So it is very easy that you can use this concept very nicely. Okay. So let's go for this particular thing. So First, I will give you all the story of at least up to some spherical harmonics. So you have y0 0. What is y00? Means L is equal to 0, M is equal to 0. So you have notation YLM. I am writing it LM. Okay. So y00, you can write as 0 and 0 kit. This is nothing but 1 upon root under 4 pi. Okay. Simple. Very simple. Now you have y11. This is nothing. 1 and 1. And this will be, just tell you, minus 3 upon 8 pi root under sine theta e to the power I phi. Next, y10 10 is equal to, you can figure it out, this will be 3 upon 4 pi, and this is nothing but the cos theta. And you have y1 minus 1, that is 1 minus 1. You have same function, minus is replaced by plus 3 upon 8 pi sine theta e to the power minus I phi. So this is the story. And yes, you cannot have y1 2. This is not possible because L is between 0 to 1. And now you can also see for the given value of L. So if L is equal to 0, then M can be 0. But if L is equal to 1, how many M is there? Minus 1, 0, 1. If L is equal to 2, how many possible M is there? Minus 2, minus 1, 0, 1, 2. So for the given value of L, how many state is there? Can anybody tell me?
12 plus
For
1.
the given value of L, how many state is there? 12 plus 1. So the degeneracy for given value of L is basically 12 plus 1. So this is the degeneracy for each state. This is nothing but 2L plus 1. This is the degeneracy of each state. Now, what we have learned? So only these four things are important. One is L square Lm is equal to L into L plus 1 h cut square Lm. This story you know. Second story is Lz Lm is equal to mh cut Lm, and two new story I have created right now, and that will be L minus Lm is equal to root under L into L plus 1 minus M into M minus 1 h cut, and this will go to L M minus 1. And similarly, you have L minus L is equal to 0. And now you can also have a story about L plus. So what will be L plus? Lm is equal to root under L into L plus 1 minus M into M plus 1 h cut L M plus 1, and L plus L and L will be 0. So if you want to revise, just revise this thing before your examination. That's it. And mainly these four things. And how you are going to apply all this thing? So let's try to figure it out. So let's straightforward go to different types of problems. Okay. So let's go for different types of problems. Okay. So first we will go for space quantization. What is a space quantization? Look at it's a very important. Let's try to understand with L is equal to 1. So we have a space, and this space is this is my Z component, this is my X, and this is my this is my X, this is Y, this is Z. So this is LZ. Now for L is equal to 1, what will be magnitude of L square? So we have three kit. What are the kit? First kit is 1 and 1. And if I will operate L square on 1 and 1, this will be 2h cut square, 1 and 1. And if I will operate 1 and 0, you have again 2h cut square, 1 0. You have L square 1 minus 1. This will be again 2h cut square, 1 minus 1. So every time the mod value of L is equal to root 2h cut, isn't it? If you take the mod value, that will be root 2h cut. Now, if I will ask you how many vector you can form for angular momentum L such that you have magnitude root 2h cut in a classical mechanics. Suppose I am doing it with the classical mechanics, then how many vector you can form which has magnitude root 2h cut? Can anybody tell me? How many vectors you can form in a space? Please give answer. It's already morning. Vivek, how many vectors you can form with a magnitude root 2h cut in general? Vivek Pandey, just tell me. Everybody is sleeping.
No idea, sir.
No idea. Manisha, how many vectors you can form?
Sir, 3.
12 plus 1, sir.
नहीं 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 मैं क्वांटम मैकेनिकली नहीं क्लासिकली कर रहा हूं. अगर मैं किसी भी वेक्टर का एक मैग्नीट्यूड दे दूं तो कितने वेक्टर हो सकते हैं?
2.
Sir, infinite.
Infinite number of vectors. Very good. So you have infinite number of vectors. So if I have magnitude root 2h cut, then I have infinite number of vectors. They have different orientation with z axis. Means in the spherical polar coordinate, if I am talking about classically, the theta is varied from 0 to pi, isn't it? The theta is fully varied from 0 to pi. So you have infinite number of vectors. But in quantum mechanics, for given value of L, if I have fixed the magnitude, then how many vectors you can have? You can have only 3 vector. For the given value of L, we have degeneracy of 2 plus 2L plus 1. What is meaning of that? You have 2L plus 1 number of M and you have different orientation. So what will happen? For L is equal to 1, we can have only 3 vectors. And this vector I can write as 1 and 1. This vector is 1 and 0. And this vector is 1 and minus 1. Every vector has magnitude root 2h cut, root 2h cut, root 2h cut. And what is value of M? So you can just calculate the value of M on this z axis. So what will happen? So this value is equal to 1h cut. This value is 0h cut. This value is minus 1h cut. So what will happen? Now your theta is not continuous. Rather, you have discrete value of theta. This is theta 1. This is theta 2. This is theta 3. For given value of L, you have only, for if L is equal to 1, you have only 3 value of vectors. So we have three orientation. So we can easily find what will be value of cos theta. So cos theta 1 is equal to 1 h cut by root 2 h cut. So that will be theta 1 is equal to pi by 4. Similarly, cos theta 2 is equal to 0 h cut by root 2 h cut, means theta 2 is equal to pi by 4, sorry, pi by 2. And cos theta 3 is equal to minus 1 h cut by root 2 h cut. So theta 3 is equal to 3 pi by 4. So what we have seen, we have seen that our space, the value of theta is not continuous for the given value of L, rather they are quantized. Rather they are quantized, that you cannot find all values of theta. But in classical mechanics, what you can find? You can find every value of theta and each have same magnitude. And this will be lie on a sphere, isn't it? This will be lie on a sphere. So this is the whole story, and you will learn this thing into atomic physics when the magnetic field is applied and how this L will be going to precise about this Z axis. So this will be just going to precise as a cone. So why we are taking that, you remember, for orthonormal condition in the last class, we have taken sine theta d theta d phi. That is nothing but the solid angle. So it will just going to precise for the given value of theta. So this is the whole story you have in this particular session. So what we have seen, that angular momentum algebra is nothing but a example of space quantization, isn't it? This is a beautiful example of a space quantization. If you have any doubt, you can just ask me. Otherwise, I will go for next problem. Now you can do for L is equal to 2. How many theta will be there?
5, sir.
5 theta. Very good.
सर एल की वैल्यू के लिए एम की वैल्यू जितनी होगी उतनी हमारी थीटा होगी, वेरी करेंगे सर।
वेरी गुड। उतने ही थीटा मिलेगी तो उतने ही डायरेक्शन मिलेगा, क्योंकि एम की वैल्यू चेंज हो रही है ना। मैग्नीट्यूड तो सेम है लेकिन ओरिएंटेशन चेंज हो रहा है। और ओरिएंटेशन कैसे चेंज हो रहा है? कंटिन्यूअस नहीं चेंज हो रहा है, डिस्क्रीट, isn't it?
यस सर, थैंक यू सर।
Okay, so should I go for next problem?
सर प्लीज वेट 1 मिनट।
लिख लो लिख लो। आप लोग सो रहे हो मुझे लग रहा है। नहीं
नहीं सर,
नहीं नहीं सो रहे हो।
सर
नहीं सर, नहीं सर।
नींद आ रही है?
नो सर।
नहीं आ रही सर।
हाँ?
सर आपकी क्लास में तो भी नहीं सोने।
नींद ही नहीं आती मेरी क्लास में, इतना खराब पढ़ाता हूँ।
इंटरेस्टिंग पढ़ाते सर।
अच्छा, इंटरेस्टिंग इसलिए नींद नहीं आती। Because if you have sweet voice, you can sleep. I don't have sweet voice. Is that is meaning? Huh? Okay. Chalo. If you are not responding, that only two means. Either I am teaching very good and very nicely that you are understanding everything, or you didn't care what I am teaching. So I think the second part is more important.
No, sir,
Isn't
because
it?
you explain each and every step.
Okay. So why you are sleeping?
No, sir.
Sir, don't consider second part.
No, sir.
So be vibrant. Okay, I know that this is online class, but we can talk little bit. Okay, so let's go for next problem. Okay, एक और problem करते हैं, then we will take एक या दो करेंगे, then we will take a small break, and then we will go for next session of problems. Okay, so and don't worry, just मैं जो करवा रहा हूँ आप उसको करते जाओ पहले, है ना? First level is this, then आगे का देखना. And please, the assignment of angular momentum algebra is very tough, so have a patience. Okay. So for the given value of L and M, or for the kit L and M, find the, for given value of L and M, find the range of delta Lx. Range means what will be limit of delta Lx. Okay. So we just want to calculate for the given value of Lm. So I am not making right now for superposition of state, sorry, eigenstate. We will do it. But right now, just we are talking about what will be happen to Lm. So what is Lx? So L plus. So if I am talking about delta Lx, that means I have to calculate Lx square minus Lx whole square, isn't it? So we have to calculate each and everything. So first, let's try to calculate what is Lx. So obviously, L plus is equal to Lx plus ILy. L minus is equal to Lx minus ILy. You can add it. So Lx is equal to L plus L minus by 2. So now, first we will just try to calculate what will be Lx. This is a very simple. So let's calculate expectation value of Lx. How you will get it? You will get it L M L plus Lm plus L M L minus Lm by 2. Now L plus we go on Lm, what you will get? Which state you will get? L plus we go on Lm, you will get what state
M
ahead?
plus 1.
So you will get some number, and let's say this number is C plus. I know what is C plus, and this number is Lm, and this will be L M plus 1. And C plus, you know what is this C plus number, isn't it? And similarly, I will get here C minus Lm, and this will be, you can have L M minus 1. So what is this value? What is this value?
Zero.
0. Why?
0.
Because M is not equal to M. M, both M is not here. Here is M, here is M plus 1. So they are different. So this value is 0. This value is also 0. So what will happen? Expectation value of Lx. The expectation value of Lx is equal to 0. Very simple. So similarly, you can tell me what will be expectation value of L square, L plus square on Lm? For the next problem, if I will ask you, what will be Lm L plus square Lm? Can you tell me what will be this value? L plus will operate on twice, so it will go up to which level? Leave the number. What will be number? Don't
M
care
plus
about
2.
this. M plus
It will
2.
be 0 again.
It will be again 0.
Again, zero.
Okay. So again, this will be 0. Again, if I have Lm, L minus square, Lm, this will be again 0. You know all this fact. Because this is equivalent to actually Lm, and this is L M plus 2. And what will be number? I don't care about number, because first I will see whether they are orthogonal or not. It is the beauty of Dirac notation that you always check orthogonality and all this stuff, isn't it? So let's try to go for Lx square, and this is very interesting. So what is, so this, I am just removing all this thing. So what is Lx square? Lx square is 1 by 4 L plus L minus into L plus L minus. You know, this is the operators. So what will be this operator? 1 by 4 L plus square plus L minus square plus L minus plus L minus L plus, isn't it? And now I have just calculated what will be L plus L minus. अभी तुरंत calculate किया था. So that will be 1 upon 4 L plus square L minus square. This thing is nothing. L square minus LZ square plus H cut LZ. Remember? अभी तुरंत किया था हमने. And what will be L minus L plus? Is L square minus LZ square minus H cut LZ. So what will happen? These two number is cancel out. And once these two numbers are cancel out, we have this operator as 1 by 4 L plus square plus L minus square, and this is 2 time L square minus LZ square. So this is equivalent to Lx square. Please always remember this is operator for Lx square. And now let's try to calculate Lx square expectation value. So this will be 1 by 4 expectation value of L plus square, and you can write, if you want, you can write something like that. So this will be L m L plus square Lm plus L m L minus square Lm plus 2 L m L square minus LZ square Lm. So what will be this value? Can anybody tell me? अभी तुरंत किया था. This value is
0.
0. This value is
0.
0.
0. What will happen to this value? So L square will operate, you will get the same kit, isn't it? So let's calculate the final one. So I am calculating here. So what will happen? You will just operate it. L square will operate Lm, you will get same thing. So 2 by 4, 4 is there. So you have L into L plus 1 H cut square. M square will operate, LZ will operate twice. So this will be M square H cut square. So this is the story. You can have L into L plus 1 minus M square H cut by H cut square by 2. So this is the whole thing about Lx square. But my question is different. What I want, I just want to know what will be range of Lx square for given value of L. L is fixed. So first we will calculate what is delta Lx. Lx is expectation value of Lx is 0. So we have to just put it here. So up to that, it's clear.
Yes, sir.
Okay. So what will happen? This delta Lx is equal to, you can just figure it out. This will be L into L plus 1 minus M square H cut by root 2, isn't it? H cut by root 2. Now, L is fixed, but M is going to change. So what will be minimum value of delta Lx? For the minimum value of delta Lx, M square must be maximum. What will be maximum value of M square?
L square.
L square, because you have the value of M between minus L to plus L, but I am interested into M square. This is the basic click. So M square is basically between 0 to L square, isn't it? So this will be maximum if this will be minimum, and this will be minimum if this will be maximum. So minimum of Lx will be put it here with the L square. So minimum delta Lx is equal to, you can put L into L plus 1 minus L square, and this will be, you can have L square is cancelled, so this, and you have h cut by root 2, so you have L upon 2 h cut. And what will be maximum? What will be maximum of delta Lx?
M equal to 0.
Very good. Maximum of delta Lx, you will put m is equal to L. Sorry, m is equal to 0. Sorry, m is equal to 0. So it will be, you have L into L plus 1 h cut by root 2. Okay, so it is the maximum value and it is the minimum value, so you can find. So this is one of the wonderful problem. We can have understand each and everything what is going to happen. I am just giving you homework. I have just calculated about delta Lx. Just try to calculate what will be delta Lx into delta Ly. Just you can get the answer. You will figure it out. The delta Ly will also equal to delta Lx. Delta Ly will also equal to delta Lx. Same thing. Now you can easily calculate. So you can see there is uncertainty principle for delta Lx and delta Ly also. Not only for x and px, y and py. Why? You have uncertainty principle because they are not going to commute. Okay. So I am just stopping, taking a break right now. We will just go for the next session. So give me 5 to 7 minute break is enough. Okay. So after the break, we will just go for next level of calculation. Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.